In this notebook, my goal was to build a strong binary classifier for dire bits binary, and I focus on two questions: what did I do to improve performance, and what did I do to assess and improve the fit? I followed a clear workflow from data preparation to cross-validation training to probability calibration and ensembling, and finally get the submission. First, I prepared the data in a consistent way. I loaded the training date, its training set, data set, and test set, data set, and look at the sample submission, separated the target from features, and removed any ID-like column if needed. Then I applied the same processing rules to both train and test, so they can end up with the same features columns. This step is important because inconsistent encoding or missing value handling can hurt generalization and even break the model at prediction time. And for performance improvement, I choose strong model that usually work well on tabular data. I trained LightGBM, XGBoost, and CADBoost under the same validation setup and compared them using F1. LightGBM reached an out-of-fold best F1 of 0.44252, and with multi seed averaging, it becomes 0.44387. XGBoost was slightly lower, but and the multi-seed average reaches 0.43839. CatBoost was the strongest single model, and the multi-seed out-of-fold best F1 reached to 0.46954. Using multiple models was not only for comparison, but also to prepare for ensembling, because different models can capture different patterns. And a major performance step was threshold tuning. I did not use the default 0.5 threshold. Instead, I searched thresholds on the out-of-fold probabilities to maximize F1. This made a clear difference. For example, that GBM worked best at a low threshold like 0.25, while CatBoost worked best at a higher threshold around 0.645. This shows that optimizing the decision cutoff is necessary when the evaluation metric is F1. To access and improve the fit, I use a five-fold cross-validation and out-of-folder predictions. Cross-validation help me to evaluate the model on unseen folds, and out-of-folder predictions give a fair estimate of generalization because each row is predicted by a model that did not train on it. I also use multi-seed training to reduce randomness. If results change a lot across seeds, the model may be unstable. Averaging across seeds makes the prediction more reliable and usually improves performance slightly. After I had stable base models, I improved both performance and fit using stacking. I used the out-of-fold probabilities for LightGBM, XGBoost, and CatBoost as meta features and trained a logistic regression meta model. I tried different regularization strengths, and the best one was C equal to 0.5. As I did the threshold tuning again on stacked output, this gave me the best result. The final stack out of four, the best F1 was 0.46990, and the threshold of 0.685. Stacking helped because the meta model learned how to combine models that make different errors, and which often generalizes better than choosing only one model. Finally, I use the best stacked model to generate test predictions, applied the best threshold, and created created the submission files. I also tested the nearby thresholds as extra submissions because the optimal cutoff can shift slightly on the leaderboard distribution. In my final attempts, my highest leaderboard score is about 0.73, and it was 0.616 CSV file. And overall, the workflow improves the performance through strong models, threshold tuning, multi-seed averaging and stacking, and it assessed the fit through cross-validation and auto-fold validation to keep the improvements reliable. Thank you.